Okay, page 45. All right, this example, they give you two different functions. It says find the domain and range of the function f, and I'm going to put f in red here. So let's do domain and range for that one here. And then I'll tell you how you have to specifically write your answer. Remember, domain is the set of all what? Really focus today because the domain and range is the hardest part. Okay, it's the hardest part, but the easiest part. When I say easiest part, there's no work to show. It's the hardest part in trying to get everybody to understand what I'm looking at. Domain, you're looking at the set of all what? X coordinates. Now, I get it's easy when you're looking at a set of ordered pairs. Like, this is an easy problem. I would do this with ninth graders. I would do G with ninth graders, but it would be something that would be, I'd spent days on it with them. I'd get them to that point. I'm trying to get this to you on the first problem. Okay, domain. It's the set of all X. So it's the set of all X such that X is equal to whatever the X values are. So just list the X values. -3, 0, 4, and 5. Now, I am totally fine. Let's see how they write the answers. So you could write the answers. What's going on here? What am I clicking? What's going on here? Okay. The domain of F is a set of X coordinates of the point in F, namely, you are allowed to write it. If you don't want to write the set builder notation on the homework, on my test, you're allowed to just write it with braces without the set builder notation. You can just write -3, 0, 4, 5. Remember, I told you set builder notation is just the fluff. It's the window dressing. It's the garnish. Okay, it just makes it look fancier than what it needs to be. So Keithan is fine just to list it like this. Okay, for the range. Range is a set of all what? Y values. So I can do the set of all numbers Y such that Y is equal to, it looks like just 1 and 2. Is that correct? Now, if you don't want to do that, and Greta's like, I'm going to save some time, I'm just going to write the range as just 1 at comma 2. That's totally fine. All right, absolutely, 100%. Okay? All right, now let's look at graph G. I'm going to do this one. This is a different function. Okay? And I know it's a different function because they named this one function F, and they call this one something different. This is function G, so we're labeling it with a different capital letter to denote that this is something different, okay? Function G is a graph. Function F, they just gave you a list of ordered pairs. Now, we could graph those ordered pairs, okay? But when you look at a graph, it's a little more complicated, and this is the part where there's not a lot of work. There's no work really to show, but you've got to understand it visually. So first of all, X is the domain. Remember I said that's the input. That's what you put in your vending machine. Okay, that's what you put in the vending machine. Now on a graph, what do you look at when you look at X? You want to look along the X-axis. And what you want to do is pay attention to how far this graph goes to the left, how far it goes to the right. Now there's an arrow here. Now this arrow is pointing down, but as it goes down, it's also what? It's also going to the left. Like I can keep this thing going forever. I'm going to run out of room. But will this thing keep going to the left? 100%. This thing is going to the left forever. How far does it go to the right? It goes to 1. Does it hit 1? No, that open circle means there's nothing there. Okay, it doesn't actually hit it. It can get closer to it, but it never gets there because there's nothing there. There's a hole there. So the fences, if you will, or the boundaries for this graph, we're going to call them fences. The boundaries would be, there is no fence to the left. How far to the left is it going? Forever. What's the fence? So I could basically play, think of your kid having a yard where there's no fence on one side. He could run out forever. Okay, like if you had a daycare or you had a dog or whatever. My wife, when she did daycare, when we first moved here, first thing we did is we got a fence. We made sure the whole thing was fenced in. There was no place where it was open. Because if there was a place where it's open, the kids could run out forever. Okay? If you had a dog fence and if you unbound one of the sides, if the one side doesn't have a boundary, which means unbounded, no fence, it's going to go to negative infinity or out forever. But the right side has a fence. What's the fence? 1. So the domain here is going to be, you can say the set of all numbers X such that, and When I do it with set builder notation, you always use an inequality. So you can say x is going to be everything less than 1. Now the reason it's less than is because I'm going to the left of 1. Less than is left. Everybody say less than is left. That'll be easy. Greater than is to the right. That's where the bigger numbers are, to the right. The smaller numbers are to the left. So I'm going to the left of 1 forever. Now, some of you don't like that way. You don't like the inequality way. You'd prefer to do the interval notation. If you do the interval notation, you don't have to do the fluff. You can just say, and the way you do it is you read it from left to right. You read your graph from left to right. So you're going to say it's everything from negative infinity up to what? 1. So you're going to do parentheses, negative infinity up to 1 bracket. Does that make sense? Okay. Now inequality, you're saying it's everything to the left of 1. But the interval notation, you're saying it's everything between negative infinity and 1. That makes sense.
Wait, why would it be a bracket?
Yeah.
Oh, yeah. What am I thinking? That's why Keithan was actually looking weird. It just wasn't. He was tired. Okay, negative infinity to 1, it is parentheses. That is correct. It's not a bracket.
I'm not tired.
Okay, he's asleep today. Okay, range. I'll do the range. I'll keep it in blue since we're dealing with function g. So this is function g. All right, the range. Let's do the set builder notation. I'm teaching both ways, so because the textbook will have both, and you get to pick which way you would like better. All right, now range is the output values, the set of y. We don't look at the x-axis. We look along so we look up and down. Domains, how wide it is. Range is how tall it is, up and down. How far down does this thing go? Forever. Negative infinity. Goes down forever. How far up does it go? What's the furthest up it goes? Don't look at the x's. Look at the y's. I don't care about x's when we're doing range. I only care about y's. When you're doing domain, you care about the x. When you're doing the range, you care about y. So it's going to be from negative infinity to 4. Now, the interval set builder notation would be the set of all numbers y such that you would go y is less than or equal to 4. If you do the interval notation, it'd be from negative infinity up to 4 with the bracket this time. Does that make sense? Okay. We'll do more examples of that in the MyOpenMath, and I'll give some practice in the homework. I'm going to give some book work. Practice it. Please practice it. All right. Let's move on. There's that. That's done. All right. All functions are relations, but not all relations are functions. Remember, a relation has to pass what test? What test is it? The vertical line test. Or if you don't have a graph, you have to check to make sure every x is paired with one y, which means x cannot what? It can't cheat. It can't go to the prom. It can't have more than one prom date. Okay. Now eventually we'll make it fair and we'll say x and y can't cheat. We'll make it what's called a one-to-one function, a monogamous relationship. Okay. A monogamous relationship. Each person has one partner. Okay. All right. So we need a process for determining whether or not an equation of a relation can represent a function, because I'm going to tell you right now, it's not as easy to look at an equation and tell if it's a function, but I'm going to give you the tricks of the trade. Now, you like that? Okay, so Brody's looking at this right like, x cubed plus y squared is equal to 1. How am I going to know if this is a function or not? I don't have a graph. I can't tell if it passes the vertical line test. I don't have a list of ordered pairs. You know why I don't have a list of ordered pairs with an equation? How many x's and y's are there when I give you an equation? Infinite. If I asked Addie for homework tonight, how about take x cubed plus y squared equals 1 and give me every point on the graph? I'd given her an impossible assignment. Why? Because there's infinite. Guess how long it would take her to do that homework assignment? Forever. Okay? All right? So it just wouldn't be good. So if you don't have the graph, you can't do the vertical line test. Some are like, well, can we graph it? Well, can you solve for y? It's a good question. Can you graph it? Well, if you want to graph it on your calculator, it has to be set equal to what? What is the calculator? When you plug a graph in the calculator, does everybody know how to use the calculators from pre-calc? You have to go to what to graph? Y equals. It has to be set equal to what? Well, let's see if we can set this equal to y, and then I'm going to give you the tricks of the trade. Okay? So I'm going to solve for y. What would I do to solve for y here? Talk to me, Goose. Subtract x cubed. Can I do that in my head, or do I have to show that? Okay, so y squared is equal to 1 minus x cubed. Now what do you do? Square root of both sides. So we're going to get y. Who remembers what you have to do when you have the square root of both sides? Plus or minus. Right there's the dead giveaway that this is not a function. Because remember, every x can only have what? Every x can only have what? But if I plug in an x, how many y's are there going to be? Uh-oh, the x is going to be cheating. If you get a plus or minus, it's not a function every time. And the reason is if you plug this into y, so I can automatically say this is not a function. So I'm going to give you little tricks here. Not a function. Because x has more than one y. And it's because of the plus or minus. The plus or minus is the problem. Because if you plug in an x, like if I plugged a 1 in for x, you would figure this out. Everybody watch this. All right, let's plug another number in. Let's plug in like, let's plug in something that'll be nice. Like if I plug in 1, I'm going to get 0. If I plug in numbers bigger than 1, I'm going to get negatives underneath here, so that's not going to work. Let's plug in like 1/2. What's 1/2 squared? Come on, do it in your head. What's 1/2 squared? Square fraction. Let's go back to pre-calc, algebra. Square fraction, you just square the numerator, square the denominator. Now you know 1/2 squared. What is 1/2 squared? 1/4. So if I plugged in a 1/2, you don't have to write this, just watch. If I did x equals 1/2 and I plugged in 1/2, I'd get plus or minus 1 minus 1/2 squared. If I square 1/2, I'll get 1/4. Do you agree now? Is everybody okay with that? Everybody's like, how do you square a fraction? I don't know. Square the numerator and square the denominator. Now, what's 1 minus 1/4? I'll do it. It's 3/4. Okay, that's called math. All right, is the square root of 3/4 going to be okay? Am I allowed to do the square root of a positive number? You would need a calculator to do the square root of 3/4. Does everybody agree? Because you can't do the square root of 3. You can do the square root of 4. So you could get like square root of 3. You could get plus or minus root 3 over 2. But you would need a calculator to know what that is. Agreed? It's a decimal, right? But the most important thing is how many answers were there? So x equals 1/2 gave you how many answers? Do you see x is cheating? That it doesn't pass the vertical line test? Now, if you wanted to plug this into your calculator, and it'd be a good idea to grab one of the graphing calculators every day, okay? And I'm going to give you 10 seconds to get over there, and I'm going to keep talking. What I would do is I would go to y equals. Now, whenever you want to plug a y equals in, you actually have to plug them both in. So there's two things you have to plug in. You have to plug in positive square root of 1 minus x squared. So everybody go to y1 and type in square root of 1 minus x squared. And then for y2, you would have to plug in negative square root of 1 minus x squared, because there's two equations. It's actually what you call a piecewise equation. And you learned a bit about piecewise functions in pre-calc, but we're going to review them in here. So you got the square root of 1 minus x squared, and you got the negative square root of 1 minus x squared. So type this one into y1, type this into y2, and then hit graph and tell me, does it pass the vertical line test? And if you want it, by the way, I don't know who had these yellow calculators for you, so I'm going to tell you right now how you reset your window when you press graph. When you press graph, if it feels like your window's wonky, press zoom 6. Everybody say it with me. Zoom what? 6. That always resets the window back to negative 10 to 10 on the x and y axis. Look at it. What is it? It doesn't pass the vertical line test, does it? No. But you ready for the trick, for the trade? All right. All you got to do is look at your equation. Look at y. You ready? I'm going to teach you the trick without having to do any work. So, you didn't get a circle? Please say you got a circle.
I got a circle.
I did not get a circle.
Oh my gosh, what is this guy doing?
What'd I do?
You put 0.5 squared in when you're supposed to put x squared.
Oh, that's my bad.
Yep. So we're doing y1 square root of 1 minus x squared, y2 negative square root of 1 minus x squared. That's where we plugged in 1/2. We did 1 point to see what it was. So how many of you got a circle? We got a circle? Okay. Doesn't pass the vertical line test. Would you like the trick? Because I never would have done any work for this. Look at the equation. Look at y. if y is ever to an even power, everybody, if y ever has an even power, when you solve for it, you're going to get a plus or minus, which means x is cheating. So just look at it. See if y has an even power. If it doesn't have an even power, it'll be a function. If it has an even power, it's not going to be a function. So is part A not a function? Why? Because the y squared is going to give you a plus or minus. Let's look at part B. Does this one, look at y. Does it have an even power? Does this one have an even power? So we should trust Mr. Morris, who said if it has an even power, it's not a function. Does this have an even power? So is it a function? Yes. Let's check it just to be sure, but you won't have to do this on the MyOpenMath. You can just trust me that the answer is yes, it is a function. But if we solve for y, you would subtract x squared, so we get y cubed is equal to 1 minus x squared. What would you do to get y by itself? How would you get y by itself now? Cube root. Does cube root require a plus or minus? All right, everybody go to y equals, clear out your y equals, and in y1, clear out y1 and y2, type in the cube root of 1 minus x squared, and let's see if it passes the vertical line test. We already know the answer is yes, but let's just double check. You don't know how to do a cube root? Would you like to learn how to do a cube root?
Yeah.
All right, it's math 4. Did you find the cube root?
Yep.
All right, type in 1 minus x squared. Press graph. Does it pass the vertical line test? Does, for sure. Okay. All right, look at C. Now, sometimes it gets really hard to solve for y. So that's why the tricks of the trade are very helpful. Because when you look at this and you're like, okay, I got a y here and I got a y here, and they're not like terms. So it might be tricky to solve for y, but the most important thing is, do you have a y squared? Do you have a y to the 4th? Do you have a y to the 6th? So what would we expect? Yes, it's a function. But I'm going to show you how to solve for y to check it. All right. There are 2 of them, but it's not a y squared. So maybe you're like, oh, Mr. Morris, there's 2 of them. Is that going to give me y squared? Is that the same thing? Let's prove it. Brody asked a good question. There's 2 of them. All right. If you were I'm going to teach you something that's very important here. This is algebra you need to know how to do. All right. You're actually going to know how to solve for this algebra. Don't divide by y. Number 1 rule, don't divide. Don't ever divide by a variable. Everybody say it with me. Don't what? It's a problem. It creates major problems in mathematics. I will tell you when to divide by a variable. Okay? Because I'm going to do it in a second. I will tell you when you should do it. What you do not want to do is you don't want to divide by it to cancel it specifically. So when we divide by a variable, the only reason we're dividing by a variable is not so we can cancel it. It's so we can get something by itself. So let me show you. All right? So I know the answer is yes. Okay? Because we're going to trust Mr. Morris' tricks of the trade. There's no y squared. There's no y to the 4th. But let's prove it. We want to get y by itself. Can anybody tell me? I want you to think like an 8th grader. How would I get y by itself? You were about to say divide by y.
No, I was going to say divide by...
Don't divide yet. We are going to divide, but not yet.
Would you move the 1 over there?
Let's move. Which way do you want to move the 1?
To the other side?
Let's move the 1 to the other side. Okay, fine. We can do that.
And then can you divide the negative 3 off?
You know, I don't know if that's... Don't write anything yet. Hold on. I'm just going to show you here. If I move the 1 over, talk to me. You got x squared y minus 1 is equal to negative 3y. Did that really help me get y by itself? Because I got a y here and a y here. Okay, so I'm not going to do that. I'm not going to do that. I'd get the y's to one side. I'd get the y's to one side. So the easiest thing to do would just be to add the what? Let's add the 3y. That makes the most sense. Let's get the 3. Now, I do like what you guys were saying. You know you got to move terms. There's got to be some kind of moving of terms, and we always move terms by adding and subtracting. That's the 8th grade algebra. Okay? So we get x squared y plus 3y is equal to 1. Remember how to do this because we're going to come back and do this in a later chapter. Okay, we got the y on one side. There's a crux move here. I'm going to put a little star by here, and if you're able to get to the next step, this is going to serve you well later. Take a y out. Factor out the y, like a 9th grade GCF. Just take the y out. They both have y in common. So what I did is I got the y to one side, and then I took it out. Now you can divide. But I'm not dividing to cancel. I'm just dividing to move it to where? That's legal. If you just want to move it to the other side. Now, why do I have to divide? Why can't I just add?
It's multiplying.
Because it's multiplication. It's y times this parentheses. That's exactly right. So I'm going to divide by x squared plus 3. Now, that'll give me y is equal to 1 over x squared plus 3. Now look at it. Just think about it before we plug this in on the calculator. If you plug in an x, are you only going to get one y? Because there's no plus or minus. So plug it into y equals real quick. Go 1 divided by x squared plus 3. I'm going to teach you how to do a fraction. Hit alpha x. Go to y equals, clear it out. Hit alpha x. Is it pass the vertical line test? 100%. So are you going to just trust me now?
Yeah.
As long as you don't have y's, as long as you don't have even powers of y, as long as I do not have an even power. Did you type it in like this? There's 2 ways to type it in. You can use the alpha x and you actually get 1 over, what was it, x squared plus 3? Now, if you don't use the alpha x, you'd have to use parentheses. You'd have to go 1 and it'll do a slash, and you're going to have to go parentheses x squared plus 3 if you do not use alpha x. So if you don't use alpha x to make the fraction, and you do it with 1 over x squared plus 3, you have to put parentheses around x plus 3, or it won't divide by all the x squared plus 3. It'll only divide by the x squared. So that's something you do need to know. But I usually teach the alpha x so that people can deal with fractions better. All right. I think that's it in 1 point. I'm hoping. Yep, that's it. Let's go to 1.4. Let's keep rolling. Rocking, rolling. All right, functional notation. All right, the objectives in this unit are to identify dependent and independent variables, use functional notation, evaluate a function, do domain and range, introduce mathematical modeling. Who's on 1.4 and doing profit, revenue, and cost yet? You are. This is going to take care of that. I'm about to give you one of the most important questions for your test coming up. Okay? All right. We described a function as a special kind of relation. Somebody remind me what a relationship is. Yeah, I just love it. I say things.
There's one x.
No, a function is when you have one x paired with one y. But what's a relationship? It's just a bunch of points. Everybody, a relationship's just a set of ordered pairs. It's just a collection of points. Everybody. So tomorrow when I ask what is a relationship, everybody's just going to say what? A set of ordered pairs, a bunch of points. Can you have a specific number of points that you can actually count? Does anybody remember what that's called when you can actually count how many points there are? Starts with a D. I've said this 3 or 4 times. Not enough, because psychology says I need to say it 7 to 8 times. It's called a discrete relation. Okay, discrete. Does anybody know what it's called when you have an infinite number of points? It starts with a C. Continuous relationship. Very good. So you either have a discrete relationship, which is you can count how many points there are, or you have a continuous relationship, which is an infinite number of points. Okay? Now, Aubrey was a special type of relationship where Keithan wants to have a functional relationship is when Keithan only has 1 date to the prom. Okay? If Keithan only has 1 date to the prom, the relationship will probably function. Okay? All right. Which one x is matched up with only one y. Now we'll focus more on the process by which the x is matched with y. So I'm going to tell you how Keithan got a date, because I know we're all surprised. All right, so here we go. If we think of the domain of a function is the input. I told you this yesterday. Remember, we're going to the vending machine. You got to put something in the vending machine. Remember, we said we could probably put nickels, dimes, quarters, dollars, $5, $20 into a vending machine, a credit card. Can you put belly button lint into a vending machine?
Yeah.
You can try, but it's not going to work. Has anybody ever tried to pop a button off their shirt and try and put it in the vending machine? Come on, you were a kid once. Did anybody try and put something else into a vending machine to see if they could get the vending machine to work?
Money.
Okay, fake money. Has everybody ever tried to use Monopoly?